Okay, let's solve question number 4, 2021 AP Calculus AB exam. I have not read the problem yet, so you're going to watch me solve it in real time and think through the problem. So we have f is a continuous function. They gave you a piecewise linear function. G is introduced as this thing. So I'm going to go ahead and make some notes to myself. This one looks like a fairly traditional question. G is the antiderivative from 0 to x of the function f of t. And I'm going to immediately make note that the derivative of g would be f of x, technically times 1. You always multiply by the derivative of what you plugged in for the t. Let's see. On what open intervals is g concave up? And give a reason for your answer. There's a nice question. So g is concave up when g double prime of x is positive. This will happen if g prime is f. That'll happen when f prime of x is positive, which means we need f of x, which is the given function, to be increasing. So there's my game plan. I always want to tie my answer to the function that's actually provided, and f is what was provided. So g prime is f, g double prime would be f prime, and if any derivative is positive, the function is increasing. That's going to happen. Therefore, g is concave up on the intervals, and g is increasing from -4 to -2. And again, from 2 to 6. Nice question. All right, number B. Let P be that function. Find P prime. Oh, nice. Okay, so P of x is g of x, f of x. They want you to find P prime of 3, so we're going to product rule. Always write down the derivative first. So P prime is g prime of x, f of x plus g of x, f prime of x. P prime of 3 is g prime of 3, f of 3 plus g of 3, f prime of 3. And now I'm going to figure out how I'm going to get those two pieces of information. G prime of 3, g prime is f, and I'm looking at my function f. F of 3 is -3. So g prime is f, and f, we just figured out f of 3 is -3, so there, that's cool. G of 3, we're going to have to do a little bit of work and come back to that one. F prime of 3 would be the slope of the given function, and I'm looking at the graph, and f prime of 3 is going to be 1. I need to find g of 3. So g of 3, if g is the integral from 0 to x of f of t, g of 3 is the integral from 0 to 3 of f of t, and we will solve this by using geometry and computing the area. So I'm looking at 0 to, oh my goodness. Okay, from 0 to 2, I'm looking at the graph, and from 0 to 2, there is a triangle above the x-axis and a triangle of the exact same size below the x-axis. Those will zero out. And so I'm really only interested in the area from 2 to 3. And so the area from 2 to 3, I'm going to do that as a trapezoid. That's going to be half the height of the trapezoid, which is 1. And the bases of those trapezoids are 4 and 3, which will be 7/2. However, this is below the x-axis, so we need to make note that that is going to be -7/2. So there is my g of 3, and I will stop right there because I'm looking at the question. They did not ask you to interpret the answer. They didn't ask, is P increasing or decreasing or anything like that. So there's no need to determine whether that gives you a positive or a negative result or anything like that. So let's move on to part C, and I see a limit. And anytime I see a limit in free response world, I work under the assumption that it will be a L'Hopital's rule problem. So I'm going to start by establishing that it is indeterminate by looking at the numerator and denominator separately. So the limit as x approaches 2 of g of x is going to be g of 2, which would be the integral from 0 to 2 of f of t dt. And so I'm going to look at the integral from 0 to 2, and that is the same section a minute ago I just mentioned is going to be 0. So that is 0. So my numerator is approaching 0. I'm going to look at the denominator. Limit as x approaches 2. My denominator, where is it, is x squared minus 2x. is 4 minus 4. That is also 0. Therefore, L'Hopital's rule applies. So I can now find the limit. I guess I'll make a note. Therefore, I will use L'Hopital's rule, which we will do the derivatives of top and bottom. So the limit as x approaches 2 of g prime of x over 2x minus 2, which would be g prime of 2 over 4 minus 2 is 2. G prime of 2 is going to be f of 2. F of 2 is negative 4. So your answer is negative 4 over 2. And something you may want to do on this, a limit only equals the function's value. So I kind of skipped over this when I did the limit as x of g of x. A limit equals the function's value only if the function is continuous. So you want to make sure that we've established that g of x is continuous. And I will establish that. We know that g prime is f and f is continuous. So I know that g is differentiable. On the entire interval, which I'm going to have to scroll up and look at my graph here, negative 4 to 6. G is differentiable on negative 4 to 6. Therefore, G is continuous on negative 4 to 6, which allows you to evaluate the limit as x approaches 2 of G by just substituting G2 into the function G. So I'm just going to throw that in here just to cover my bases. They may not require you to write that, but it doesn't hurt. So moving on to D, find the average rate of change of G on the interval negative 4 to 2. Okay, so that average rate of change of a function is G of 2 minus G of negative 4 over 2 minus negative 4. I forgot the negative. So I would write that down first. You probably get a point for that. I know G of 2 is 0. My denominator is going to be 6. I need to find G of 4, so I'm going to come over here. G of negative 4, that is going to be the area from 0 to negative 4 of f of t dt. So let's go back up here. 0 to negative 4, I'm going to, see, that's going to be a negative area altogether because we're going from right to left in the regions above the x-axis. I'm going to break that up into a rectangle with area 8, and that's going from 0 to negative 2. There's a triangle above that with an area of 2, and then from negative 2 to negative 4, I see a triangle with a base 2 and a height of 6, so that's going to be an area of 6. And so we get an answer, a value of negative 16. And so I'm getting negative 8/3 for the average rate of change of G. All right. Then it says, does the mean value theorem guarantee a value C for which G prime is equal to this average rate of change, and justify your answer? Does the mean value theorem? I want to say yes. So what we have to be sure of is whether G is differentiable. And G is, this is what we talked about earlier, G is differentiable because I'm looking at its derivative. The derivative of f is, they're not asking you to find C, does it? This is what confuses. Usually they ask you to find the value of C. Does the mean value theorem guarantee a value of C for which G prime of C is equal to this average rate of change? Yes, it will. I think all they're asking you to do is establish that G is indeed a differentiable function. Yeah, and I'm going to say yes, it does. Because G prime of x is equal to f of x, and f of x is continuous. Therefore, G of x must be differentiable and we are specifically looking at the interval negative 4 to 2. And we do know that, yeah, so differentiable on negative 4 to 2. So mean value theorem does apply. I think that's what they're looking for. There we go. I don't like it that they're not asking you to find C. Maybe there's not enough information for that. Looking over that one again, how much time have I spent on this one so far? 10 minutes? Okay. Average rate of change of G is that. So we got negative 8/3. Does G prime, which would be F, equal negative 8/3? Did I do that right? Oh, I made a mistake. Whoa, I just caught this. I'm glad I double checked this. So this isn't going to change my answer. So I have an answer of negative 8/3. And in my mind, I was thinking that G, which has to be F, should be negative 8/3 somewhere on the interval, which doesn't happen on the graph. So I had a contradiction in my answer. This is 0 minus a negative 16. So I need to fix this. The value of G of negative 4 was negative. So that'll be 0 minus a negative 16, which actually gives you an average value of positive 8/3, not negative 8/3. So I caught that error. And that does happen. That does happen very early on, somewhere between negative 4 and negative 3, according to the graph. So yes, it does apply. Okay, I like my answer. I'm going to stop here and move on to question number 5. Is that where I am? Yep.